Good afternoon, Hygiene.
Hi, good afternoon.
Thank you so much for agreeing to this.
Yeah, you know the struggles. It is well.
Amen.
No, no, no.
Good afternoon, everyone. So, Olumide, who was taking us our last week, or who took us our last week, said he won't be available, like it was so last minute. So today we won't really be talking about our programming. And but from next week, hopefully we should go into Python. You know, he advised that we learn Python before our. So from next week we should be doing Python. But for today, IJ will be taking us to this session, but it won't be based on our. It's just a recap of what we've been doing. And you know, as Dr. Francis always says, we have to keep practicing, otherwise we lose knowledge of what we're doing as data analysts. So thank you. IJ.
Hello, everyone. Hello, good afternoon. Yeah, so thank you, Chinoye. Yeah, unfortunately, Oba couldn't make it today. Today, we're about 6 on the call, no 7. So, and from the faces, I'm sure the people here are data experts. In fact, you guys are consultants, you know. So I won't be teaching per se, but we'll be solving a problem together, a data problem together, right? Is that okay?
Yeah.
Okay. All right.
Yeah, that's
Awesome. Okay, so let me share my screen. Please confirm if my screen is visible.
You can see your screen.
Awesome. Okay, so we have a problem. We have a problem before us as data scientists, right? Let us imagine that you are hired by, or you are hired by a company that works in healthcare, right? And you've gotten some healthcare data and you want to offer insights based on this data, right? What we are going to be doing today will be based on Excel, Microsoft Excel that you all know, the same Excel you use in school every day. But what we'll be doing will be we hope to take it a little further than what is done in school. So by way of recap of what you already know, we know that there are several types of analytics, right? The basic one is descriptive analytics, right? Descriptive analytics is just, as the name implies, describing, all right? It asks, what are we seeing? Can we see it? What are we seeing? Right? So there's a picture I like that is really graphical. This is it. I have to Google it out. It gives a pyramid for the types of analytics, right? So at the base is descriptive analytics. I'm sure every one of you can do descriptive analytics. Descriptive analytics basically answers what is happening, right? What is happening? What is happening? What is happening, right? What is this? It answers the question of what. So what are we seeing, right? What is happening, all right? So the next level of analytics that builds upon descriptive analytics is diagnostic analytics. I'm sure we all know all these ones. So it's not strange. Diagnostic analytics. Diagnostic analytics, I just want us to build from what we know to what we do not yet know. So diagnostic analytics tries to answer the question of diagnostic analytics tries to answer the question of why, right? Why is it happening? Right. The next one next level of analytics right? Analytics. Next level of analytics is predictive analytics, right? What is going to happen? So you have a problem has come to you, you have seen the problem, you have seen what is happening. Next question is, okay, why is it happening, right? The next question is, okay, can you predict what is likely to happen in the future, right? Next question is, what should be taken? So when I try to understand these things at first, I looked at it as, imagine somebody you know being sick, right? And you have to go to the hospital. If you go to the hospital, the first thing you go to tell the doctor, oh, these are the things that are worrying me. Oh, I am having malaria, I am having fever, headache, cough, catarrh, or whatever. And then the doctor now looks and says, why are you having all these symptoms? Let us do tests. So they go and run tests to diagnose you, right? When they say, after the results comes out and you see that, okay, this person has malaria, what's the next thing? They will say, if you don't treat this malaria now, by the next 2 days, you'll be able to go to work, right? So they predict that it's going to disturb you. And when you now do that, the next step will now be, okay, what do we do, right? Then they can now give you drugs, they can now give you medications, right? Then the last step, you can now say, okay, what can we do to ensure that you don't have this problem again? We now say, okay, let us change some things in our environments to make us better. So at that time, you are now adapting your environment and creating an autonomous system around you to prevent the problem from happening again. So I want us to follow the same framework in our heads, right? I'm also saying this framework because I have a data set that I would like us to work on together. And the data set is in healthcare. So that's why that's part of the reason I'm using this example. So descriptive, diagnostic, predict, prescribe, adapt, right? Okay. So this is so predictive analytics, then adaptive or autonomous. Adaptive analytics. All right. So these are the 5 areas that we want to be looking at today. So when we are talking descriptive analytics, what are we talking about? Anybody has any clue? Well, am I muted? Can you hear me?
Yeah.
Oh, okay, great. So I'm sure we already know that predictive analytics is, right, as the name implies, predictive analytics. So it answers what will happen. Basically looking into a crystal ball and saying and telling people that this is what happened in the future based on what has happened in the past, right? And then prescriptive analytics, what should we do? Answering the question, what should we do, right? Or what should we then do, right? So this asks, how do we change our environment, or how do we make things automatic, or what do we change? What do we automate? Okay, so I have some real life data here for you, right? This is data from Nigeria, our country, right? And I was able to lay my hand on it by searching for a survey. A survey was done in 2021 across the country, across 36 states of the country and the FCT, right? And this survey was on issues around healthcare in Nigeria, around primary healthcare in Nigeria. So just to let you be familiar with the headings, maternal and newborn, the meaning is obvious. Refers to the health of pregnant women and their newborns. Immunization data, so refers to those people that come to your door wearing, sometimes they wear overall and say kick away polio or roll back malaria or something. So they do immunization, right? And I will delete this data because we couldn't get data on this. So I'll just delete this one so that there won't be any confusion. Then there was data on malaria. Or let me just delete. Then there was data on malaria. And malaria, this LLIN was on long-lasting insecticide nets. That is looking for how many people actually use insecticide nets in the country. So then this was on nutrition. How many babies are exclusively breastfed for 6 months, and how many children are receiving vitamin A supplements in Nigeria. This data set was made available by a survey, and we have the data for the entire country. So I wanted us to use this data to walk through these steps because this is research data. So I wanted you to walk through these steps and see what insights we can generate from these. Is that okay? Can we do this? Can we go?
Yes.
All right, awesome. Awesome. So when we're talking descriptive statistics, descriptive analytics, right? We are talking, we want to visualize, we want to see. Right? We want to see what is happening. So the way to see what is happening, the way to know what is happening is by charts, graphs, and tables, right? That is how we see what is happening. So all you can see here are just a bunch of numbers, right? I can copy this data set and put it on the charts so that in case you want to see what we're talking about, it wouldn't be that big of a deal. Let me see if I can put it on the charts so that if we can be working on it together if you want. Let's see. Test data. Let's put this. Okay, so I guess I have to close it and reopen. So let me close the file first, and then reopen it. Just give me a minute. Let me add it to the charts. Yeah, so I think I put it on the charts, right? So I'll share my screen again. And we could recommence. Okay, can you see my screen now?
Yes.
Yes.
All right. Okay, so first question we want to answer is what is happening? So what is happening here? Charts, graphs, tables. So for those of us that have been here for a while, we already know how to create dashboards, because you have to have a place to put all your charts and your graphs. So that's a dashboard. So to create a dashboard, create a dashboard. We will create a new sheet. Name it dashboard. Okay. Can we remember how to remove grid lines? How to remove all these lines?
Yeah.
So we, okay.
And take out the grid lines.
Okay. See, voila. Grid lines are gone. We can also remove the formula bar so that there'll be space. And behold, we have a plain white canvas for us to paint our charts. So we've done that, right? But we know that before we start even creating charts, the general format is data, you clean, you analyze, and then you visualize. Data, you get your data, you clean it, analyze it before you visualize, right? So we have our data, but we need to check whether it's clean. And by clean, we're talking empty rows, empty columns, texts, where numbers are supposed to be, you know. So, does this data look clean to you?
No, it doesn't.
Okay, so they are empty, there are two empty columns, right? So a lot of missing data. So when there's missing data like this at this extent, of course, we can't start manufacturing numbers. If it was just one row or even one cell, we could have found options like the average, options like the number above or the number below. You know, we could have just dragged down, but this is an entire column. We can't just manufacture numbers. So we are deleting these two. I will delete. Voila. Okay. So now that I deleted those columns, anything that's making it not clean. So we have this. There's an entire row here that is empty. And this will likely affect our analysis. So what do? We have the data here as zone. So let me expand it so that we can see. The data is given as North Central, Northeast, Northwest, Southeast, Southwest, Nigeria. Then we have the data for the state. So it's about two data sets in one, right? So what do? Separate them, right? Separate them. So if we separate them, it gives us, we separate them, we put them somewhere else here. Okay. And then we can now move, because what we're interested in is actually the states. We're interested in the states. Okay. So, so we clean it, copy it, and voila. So we have our states, we have our numbers, and do we have many missing cells? Yes, we do. So just visually going through the cells, we can see there's some asterisks. So what do we do? What do we do about these asterisks? Do you think it makes sense do you think it makes sense to just drag down? Or do we do the average? What do we do? Anyway, so since we have domain knowledge, because we're talking about statewide data, we're talking about Nigeria's data in total, we can see that the place where there are missing cells, for example, this is Cross River. What sub-region, or sorry, geopolitical zone is Cross River from? South-South, right? And we have the data for, we actually do have the average for South-South. So the option would be, we could take the regional average and put it there, right? So let's do that. This is Cross River under column I. What's the average for South-South under column I? We take this 61 and we put it there. Same for Ekiti. Ekiti, that would be Southwest, right? Ekiti is Southwest, so we take the same thing and fill it. So nutrition, we are looking for, Cross River is also missing. So we go there, copy, and we paste the average there. Same thing we do for the Ekiti, the missing cell, right? So now that all cells there are no empty cells. So usually, remember what Dr. Francis used to say, and I think I'll reiterate it, that data cleaning is usually the longest part of data analysis. So what we want to do, clean, analyze, visualize. Analyze and visualize are usually very fast, but cleaning is usually the long, boring part. So we can see that there are some numbers in brackets, and you can't analyze numbers in brackets. So what do? We remove the brackets, right? So how do we remove brackets? We could use Control Find.
Replace.
Find and replace. Sorry, what am I pressing? Okay. Do this. What are we replacing it with? Nothing, right? I'll replace all. I removed all the right-handed brackets. Do the same for the left side.
Nothing or negative. You do nothing, it means it will show that it's not a negative number. Is that correct?
Okay, so we leave it empty, right?
Instead of empty, we make it negative sign.
Negative. Okay, let me see what you're saying. All right, so I put the brackets back, and then I press my Control F for find, and then you're saying here we put negative.
Yeah, that is if those numbers in bracket means negative.
Oh, okay. So what you're saying is that if it was like an accounting figure.
Yeah.
Okay. Yeah. Well, these are not. I get what you're saying. Hope you get what he's saying. That if it was an accounting figure, you can just do the find and replace this way. But if not, you leave it empty because you want their absolute figures. So we leave it empty. The reason why they put them in brackets actually was because there was some explanation that they wanted to do on these figures. But I read the explanation and it's fine. We can use the absolute figures. So replace all, And we do the same for this, for the other side, replace all. Voila. All our data is without brackets. Is this clean enough? Ah, we missed the spots. We missed the spots. Sokoto. So we pick the average for Sokoto column F. Sokoto, is it not west or not central or northeast? Sokoto, I think Sokoto should be northwest. Sokoto should be northwest at the Caliphate. And so we put it. Voila. So we have all our data ready for analysis. Ready for analysis. So we've done this, check. What is left is analyze and visualize. So let's analyze. First of all, we have to remove every data set around the table, right? So it is bad practice to leave data around a table. So let there be space, right? Or around a data set. Ideally, all these are not supposed to be here. In fact, all this text, should remove all of them. But just for the sake of our conversation today, let's just leave them. But normally they're not supposed to be there. So we have all the states in the country, and mind you, these are actual data, right? These are actual data that was conducted by a world-renowned survey in 2021. So whatever data you see, whatever result you see, if you see your states doing badly, just take it like that, right? Don't fight the messenger, right? So let's go. Ideally, also, this is not supposed to be here. This top supposed to be just states and this, right? So we could remove this excess. It is not very good practice. We could put them here. I don't just want to delete them. Copy these, paste them here, and then copy the entire thing and paste it here. This is what we need. So let's go. Do we want to describe our data? Let's describe our data, right? So can anybody remind us how we describe data on Excel? There's something that we can do, and we can just get mean, median, mode, everything on Excel.
Oh, I think it's data.
So I should go to data.
Good. So I think it's a data analysis. Data analysis.
If you haven't downloaded data, if you haven't installed this data analysis on your computer, I suggest you do. We use it a lot in DA Club, and you even need it when you're doing regression in finance. But okay, so data analysis.
Then descriptive statistics.
Descriptive statistics are doing very well. Okay, so input range. Our input range is everything, right? What's our input range? Everything here. Do we want to describe them one after the other? Describe contraceptive prevalence, then describe delivery, for these acronyms, ANC is antenatal care. So antenatal care is the number of people that have had one antenatal care visits. ANC4 is number of women that have had up to 4 antenatal care visits, right? So just for those of us who are not familiar with these terminologies. So let us describe our contraceptive prevalence. Describe column. Should we do label in first row? think we should do labeling first row so that we can pick this. Right, be good, and then put it on a new worksheet. Summary statistics. What's our confidence interval? 95%. Usually in almost every industry, banking, whatever, oil and gas, your confidence interval is usually 95%. However, in healthcare, if you're dealing with human lives, like one-on-one human life, you usually use 99% because you want to be as accurate as possible. But for the purpose of this, this analysis, let's just stick with 95% as a general, because it's 95% you will likely use. So it's grouped by columns, and let's see. So we have this. This is what we have. Contraceptive prevalence rates we have described. And as we can see, the average contraceptive prevalence is 22%. So why I like to do this first is because it gives you, or why the teaching is to do this first, because it gives you a very broad overview, right? So without even visualizing anything, you have begun to see what to expect. So on average, only 22% of people, or women rather, use contraceptions in Nigeria, regardless of states, right? The median is 22.5, the mode is 23. I want to believe we all know what these ones mean, median and mode, right?
Yes.
This is middle, this is most. Then standard deviation of 10, variance of these. Don't bother yourself with all this kurtosis, skewness, you know, but at least important to know is minimum and max. So the minimum number, as the state with the lowest is 7, has 7%. The state with the highest has 45% of their women using contraception. When we visualize, we will discover which state this is. So there are 37, just to be sure that we picked all the states in the country plus the FCT, right? So having done that, we can now visualize, we can now visualize where we sheet 1. So we want to see contraceptive rates, right? So remember, we're still working with this. We've cleaned, we've done some basic analysis. We want to visualize it. We all know these ones. So let's visualize. Insert. So what chart will you want us to use? Should we go to the charts? Should we use the recommended charts, or pick a chart by ourselves? I very much like to use recommended charts. Voila. Voila. And I think generally, maps tend to help us a lot, because you can easily just see. So we press OK. And our chart comes up. I rename the charts contraceptive prevalence rates. Okay. So where do we have where's our highest? 43%. You can just hover your mouse over it, and we're looking for the place with the, oh, it's Lagos. It's Lagos. So we can add data labels. If you're not using the latest Excel, you can't do this, because this map function is it's addition on Excel 365. Microsoft 365. So yeah, you want to add data labels for everything, but it look clumsy. So we can just pick one and add data label. Right click. It should be with format data label. No, it's not working. There's a way to just add that, to just show that Lagos, just to pick just one data item. Anyway, I'll figure it out, but yeah, at least this just gives you a broad overview. So we can carry our first charts, copy it or cut it and put it on our dashboard. So there we go. At least we can already see that it's the Southwest that is the Southwest and Southeast are the ones that are doing well as far as this this data set is concerned. But let's continue and see what the other ones will tell us. So same things, states, control shift down, pick everything, inserts, our map, and okay, what is this measuring? Delivery by skilled at birth attendants. Delivery by skilled birth attendants. So this measures of the women that give birth in these states. How many of them were actually attended to by somebody that knows how to deliver women, right? Not by not by those who delivered by themselves in their house or something. How many actually saw a doctor or a nurse, right? We can see this, we can already see what is happening. Many of the states that have the highest rates are in the Southwest. You can see our Lagos here having a rate of about 71%, right? You can see states like Imo states. That means 96% of all women in Imo states deliver with somebody, a trained attendant. But if you look at the places where the blue scale is lightest, you can see states like Bauchi, only 17% of the women that deliver in Bauchi states are actually catered for by a skilled birth attendant or by a doctor or a nurse. So you take your data sets, you put it there. You're already telling a story, right? Things seem to be better in the South than in the North. But let's continue and see. Let's pick another data set that affects children. How many children are receiving their Penta vaccine? So just for general knowledge, Penta vaccine is a vaccine that contains about five different vaccines all in one. So if you've been listening to the news, there has been a diphtheria outbreak in some parts of the North, right? So in those parts of the North where there's been diphtheria outbreak, normally this diphtheria is not supposed to happen in people who have received this vaccine, this Penta vaccine, because diphtheria is one of the components of the Penta vaccine. So let's see the rate of adoption. Ideally, it's supposed to be every child is supposed to have received this vaccine before they are 3 years old. Let's see what the national average is. The national average for the Penta vaccine is 20%. That means in this Nigeria, only 20% of children on average receive this vaccine. But let's see the numbers by states. You can see there's a problem in this country. Let's see the numbers by states. Okay. Okay. So, infants receiving penta vaccine. Percentage. Okay, so who is highest? Adamawa is our highest. Where is our Lagos? 8.3. People can argue with this data, but this is the data that we have. So let's copy it and paste it. Chino, what state are you from? Let's see how your state is performing.
Abia State, let's see.
Okay, so let's see what Ikpeazu was doing over the past 8 years. Where is Abia? It's around here. No, not Ebonyi, not Enugu. That's Imo. Abia, 20%. Wonderful.
We try.
So, so let's go to some other data points. For the sake of time, we won't do all of them. Just do a few. So we've checked out penta, checked out measles. Oh, let's not check out measles. Let's move on to something under malaria. So the teaching is that usually for pregnant women and children less than 5, they are most susceptible to malaria, which is why the government usually advocates that everybody, pregnant women and children under 5, sleep under mosquito nets. So even if nobody else is sleeping under mosquito net, those 2 particular people, the government is always particular about them sleeping under mosquito nets. So the target for the government is that bad as it bad, as bad as it bad. The target is that 80% of all women sleep under mosquito nets, and 80% of children less than 5 sleep under mosquito nets. However, the national average is 73% of women and 69%, almost 70% of children. So let's see how each state performs, right? So we do the same thing. We pick each state. Pick each state, Control Shift down. We come here, Control this, Control Shift down. This is for pregnant women. We'll find our charts and we pick it. And we say we rename the charts pregnant women under insecticide nets. They call it LLI, and that's long-lasting insecticide nets. Because ideally, the insecticide on the net is supposed to last for a long time. And this is the reason why they usually share it free for people. Many of us might have in our house, but we never use it. So dashboard, put it here, reduce the size, and we arrange it here. So let's see our states. Lagos. Okay, it's Lagos. Where's Lagos? Lagos, only 45% of pregnant women sleep under mosquito nets. Let's look for Chinoyen states. It's even better than Lagos, 51%. So who is the best? Adamawa seems to be doing well on every chart. Almost 90% of them, even above the national average and national targets. So, sorry, let me just be calling people's names so that we'll be looking at your states, how your state is doing. Sir Joshua, which state are you from, sir?
Kwara State, sir.
Sir?
Kwara State.
Kwara, let's see Kwara. Where is Kwara? 63%. Well, you have a B. Let me pick up. Let me look for somebody else's trouble. Who else is on this call? Joy. I think I see Joy's name. Joy, what state are you from? Okay, Joy is
Hello,
able.
you said what? Did I hear my name?
Yes, so we're looking because
Sorry,
we are creating scorecards for each of our states. So what state are you
Oh.
from?
Edo State. Proudly from Edo State. Thank you.
Proudly Edo State.
Good afternoon, everyone. Yeah.
So let's see Edo State score. How many women in Edo State are sleeping under mosquito nets? Okay. Edo has failed this exam. 46%. 46% of women in Edo State sleep under mosquito nets. Right. The national goal is supposed to be 80%, but it's okay.
We'll get there.
We'll get there. We'll get there. Okay, so so at least now we have an idea. We've done some descriptive analytics, right? We have our charts, so we can see what is happening. You can see what is happening in your states. We've seen what is happening in Abia State, in Kwara, in Edo, in Lagos. But the question is, why is it happening? Right? Every policymaker is worried about why is this happening? Now that we've seen what is happening in your state, why? What are the reasons? Right? So for example, let's take the first data sets, contraceptive prevalence. Why is it that in some states, some women or some people are more likely to adopt contraception than others? Now we could now brainstorm together and say, why? So to help us, well, we might have from our domain knowledge, we might have some reasons. Okay.
Culture.
So let me just write it in here. Culture. What else? Could religion play a part?
Yeah.
Religion.
Ignorance. Some people are not even aware.
So how do we measure ignorance? Because we are data science, we have to think like data people. Can we measure it by literacy rates? People that went to school?
Well, we can. Okay,
so since we've identified ignorance as a problem, we can use a data proxy, and say literacy. If we have any other data proxies, we can always add them. So culture, can we measure culture? Is it possible for us to measure culture, to find a data set that speaks to culture? That might be difficult, right?
It might, unlike religion. Religion is easier to.
So we can actually find a data. If you want to say, the question we're asking is, basically we want to now ask, is there any association between religion and contraception? That's the question we want to answer now. If there's any association between these two, right? Between religion and contraception. So let's look back at our data. So we will now have to get data on religion in each state, right? How many Christians, how many Muslims, how many traditional worshippers, and compare with contraception rates. Is it higher in Christian areas? Is it higher in Muslim areas, right? Right now, we don't have that data, but these are the ways that we can be thinking about it, about solving this problem. So, but just by looking at the charts, look at these contraception rate charts, right? Can we begin to hypothesize a reason or a religion, or an issue around religion? Because Kwara and Oyo, which have high contraception rates, they also have significant Muslim populations. Same with Lagos, right? But states that are that have a significant states in the north, like Sokoto, that is the seat of Islam, is where the caliphate is and has a very high population, now has a low contraception rate. So what is happening? States like Jigawa, Katsina, that from our knowledge of Nigeria have high Muslim populations, have low contraception rates. So is there any relationship between their religion, Islam, and contraception rates? And we're not talking, we're having this conversation not as religious people, or we have to disabuse ourselves from our biases and start looking at the numbers. So in the same way, Christian population, Anambra, largely Christian, largely Roman Catholic, actually, or largely Christian, and yet has a high contraception rates. Almost half of all women in Anambra State are comfortable using contraception, use contraception, right? But again, Bayelsa State, which is also a largely Christian state, still has low numbers. So if we had the data, which we do not, we could now run, what analysis could we do to actually tell us that there is an association? What analysis do we use to run association?
Regression analysis.
Regression. Is there any other one?
Correlation.
Correlation. Any other one? Those are the main two. Those are the main two, actually. And it's very unlikely you will ever need anything more than these two. When you do Python, when you start Python, you would see regression and correlation coming out again later on, right? Because we can do regression here on this Excel because the data is small. It's just 37 data points, right? But when you have data sets of maybe 20,000 customers, you might not be able to run that on Excel, or 2 million customers, right? So that's where you now use Python. So yes, regression and correlation. Regression and correlation can now tell us if there's any association between religion and contraception, right? So literacy. Literacy, do we have any data sets? I think I had one data set for literacy. Let me just quickly check. I had one data set for literacy. There was a data set I saw that told us literacy rates in different parts of the country. Adult literacy. Adult literacy rates, regions, Nigeria. Let's see. Behold, have data points, but these are regional data. Do we have regional data here? Yes, we do. So let's copy these data sets, right? Let's copy this data, minimize, bring this up, and we could add this. We could insert by the side. We could insert a column and say literacy rates, or no, and say literacy rates. We don't have literacy rates by states, but at least we have by the geopolitical zone. So it even gives us male, female, which is even more interesting. So we will insert this. Male literacy rates, female literacy rates. So in North Central, what do we have? Oh, It's not showing. We'll find it. Northeast, not showing. Northwest, 59% for men, 29% for women. Southeast, 86.7% for men, 79.3% for women. South-South, 88.5% for men, 79% for women. And the Southwest, 89% for men and 80.6% for women. Let's see, by the time we open it, we can see for the Northeast and the North Central. So Northeast, this is from Statista. So North Central rather, 72% for men, 72% of men in North Central region are educated, can read and write, while only 49%, 49.6% women are. In the Northeast, 50.5% for men and only 31%, 1.8% for women. So we can now maximize this because we have collected the data we need. And so even though we do not have the data sets for all the states, can we do some analysis, some regression analysis to see associations between the regions? We can do that, right?
Mm-hmm.
So just to make this complete, let me put the heading of this one: contraceptive prevalence rate. Mind you, I found this data interesting because this actual real life data. Everything here is actual real life data. It's not, we didn't just manufacture something. So let's see how our country is doing, right? So how do we do regression? Can somebody lead us how we do regression? How do we regress?
Same way we found descriptive statistics.
Okay, so how do we get to that place where the descriptive statistics?
So we click on data.
Data.
Data analysis at the end.
Data analysis at the
option.
So what are we looking for? We're looking for regression, right?
Yeah.
I'm looking for regression. But before we even do that, can we do a correlation first? So to do a correlation is even a lot easier. It's equal to Correl. Is equal to Correl. I hope we are familiar with this. Equal to Correl. So what are we correlating? We are correlating this. And we are correlating, let's pick only the data points. Correlating contraception prevalence with, let's correlate it first with male literacy. Is there any correlation? Press enter. So 91% correlation. Let's see. But let's see female literacy. Let's see if there's any correlation between female literacy and contraceptive use of contraceptions. So equal to Correl, right? First data sets, this second data set is female, 88%, right? So what does this mean? What does this
relationship?
Okay. So correlation just tells us that as a number is going in this direction, these two numbers, it's just measure the level of closeness in the direction that both trends are going.
Yeah.
Right? So it's saying that this correlation is now telling us that there is a closer association between male literacy and contraception prevalence in women. Isn't that strange to you? Wouldn't you have expected that it is women's literacy rates that would affect contraception prevalence? Because it is women, because contraception is usually done by women. So we've seen it just shows that the beauty of analysis is that if you analyze objectively, right, the data might show you things that you did not expect. So expect the things that you did not expect to see. Expect the unexpected. So we've done correlations. Let's do regression.
I was going to ask, as regards correlation, correlation doesn't necessarily mean causation. Is it possible that maybe it's not the cause, it's just data is just showing what it's showing?
That is very true. In fact, that is one of the most important tenets of data and of data science. Correlation does not prove causation. Does not prove causation, right? So, yeah. So just because there's a strong correlation between both does not mean that one is causing the other. It does not mean that male literacy causes contraception prevalence, right? What if contraception prevalence is causing male literacy? It sounds weird, but what if people that are, well, as women are having taken contraceptives, somehow it makes their men start knowing that? I don't know, but data says generally, right? This does not necessarily prove this, and this does not necessarily prove this, right? Actually, there could be a C. So A does not necessarily cause B. Sorry, let me put A may cause B. B may cause A, or there might be a C, a different factor that we have not even considered that is causing both of them. Right? So this may cause this may cause this, and something else may be causing both of them to be going in the same direction. So that is left to our own understanding of domain, our understanding and domain knowledge of things, of these topics. So we've done the correlation, right? But have you ever wondered how you prove causation? Because if we say that there's a correlation, but it doesn't necessarily prove that male literacy causes contraception prevalence. So how do we prove that something causes another thing?
Isn't that where regression comes in?
Well, the truth is that even a regression might not be able to tell us that. So as while correlation measures the level of closeness, regression measures the level of variance, right? But still, it still does not tell us causation, which is why there are 3 rules. I can't remember what it's called, but there are 3 rules that prove causation. I will remember it. I Googled it, I checked it one time. I can't remember. Maybe when I get it, I'll put it on our group. But there are rules that prove causation, right? Data scientists are not really always in a hurry to beat their chest and say this is causing this, but there are actually rules. One of them is that it must make logical sense for B to cause A. It does not make logical sense right now. It does not make logical sense that contraception will cause male literacy. but it actually it can make logical sense that male literacy can cause contraception prevalence. But that's another conversation. Let's just move on to regression. That we don't build house on this one, right? If we do a regression, I'm sure we already know how to do that, but the same steps: data analysis, regression analysis. Where's my regression? Regression. Okay. So what is my Y? Y is what we are looking for, right? So what is my Y? We are saying Y is a factor of this. So contraceptive prevalence is a function rather. Y is a function of this. So contraceptive prevalence, what we are saying that contraceptive prevalence is it a function of male literacy? What labels are there? Confidence interval. So let's see. Is it a function? Let's see what it tells us. Oh, very wonderful. So we can see an R square of this. Is it statistically significant? That's the first thing we should even look for. What's the p-value? Is it less than 0.05? Yes. Yeah. So there is a significant association between male literacy and significant association between male literacy and contraceptive use prevalence in Nigeria. Nigeria. Okay. So should we do the same for females? Let's do the same for females. So contraceptive data analysis, regression, our Y stays the same, but the next X we want to examine is female literacy. We pick it, we press OK, and voila. What's our p-value? It is still less than 0.05, right?
Yes.
So we pick the same statements. We're saying, okay, we agree that there's a significant association between female literacy and contraceptive use. Now let's see the two of them combined together and see their combined effects on contraceptive prevalence, or their combined association rather, combined association. So we go to data analysis. Data analysis, okay, regression. We press OK. For our X's now, we're combining both. So, right, and let's see their combined effects. So this tells us that, this is funny because it tells us that we can't analyze them together. Their p-values combined, if we put them together. Wait, let me do this again. This is very strange. Let's redo it. Data analysis, regression. We pick these, right? And then this, we pick these. Right. And we press OK. Interesting. Okay. So it is. I'm really not sure why why it's not giving us a p-value less than 0.05 when they are combined. Rather, when they are separate, it gives us a p-value of 0.0 of less than 0.05. Appears strange. But the R-square is still quite high. Anyway, so it appears that individually, they tell a story, but together, they're not telling the same story. Anyway. Okay, so but we understand the idea behind this. I think I'll have to investigate this data. Dr. Francis used to tell us something, that if you torture the data, it will confess anything. So I guess with time, we'll torture this data. That's after this meeting, after this, I'll probably torture this data more and find out the reason why that is the case. But I just wanted us to understand this, that in finding out the association between, finding out why something is happening, we can use correlations and we can use regressions, which is what we have tried to do. And we're trying to find significant associations between them. If you like, if you have the time, you have the power, you can actually look for data sets that speak to the other factors that we identified, religion, and then try to see if there's any significant association between both, right? When there's not significant, if there's any significant association and you have high correlation scores, high regression scores, then you can now start saying, look, you can now start trying to draw inference from there and saying, maybe this is happening because XYZ. For example, maybe generally in healthcare, we know that those with domain knowledge in health know that a lot of women do not make decisions on their body without informing their husbands yet. And their husbands, a lot of the time, will determine whether they do something or not. It's unfortunate, but it's the truth, right? So for those with some might argue that as much as you're educating the woman, right, you should also educate the man, because a lot of the time culture makes them depend upon their husbands for counsel before they do anything, before they do make steps as important as taking long-term contraceptions or contraceptions in any way. And if the husband is not well informed, not well educated, he might stop this from happening. So when we analyze this data, because full disclosure, this data set was being worked on by I and a group of people. So these were some of the reasons why some of the reasons that we possibly came up with, right? Of course, we can go back into the culture, and if we want to prove this, we can now go back to the women and ask them, how do you make your contraceptive decisions? If you were to do a contraception, if your husband tells you no, will you still go ahead? If you do that across the country, and you get data from each state, and women in each state are telling you, I will do this without my husband, or I will do this with my husband, then you can now have an idea and say, okay, male literacy can affect this, or female or male literacy is not needed to affect this. Do you understand what I'm saying? Am I speaking in tongues or am I speaking English?
I understand.
Okay. Okay. So on to the next one. Predictive. Oh, we have about 30 minutes left. Okay. So predictive analytics seeks to answer the question, what will happen? Right? Let me take this away from here. So seeks to answer the question, what will happen? So you're basically trying to be look into the crystal ball, have a crystal ball and see, based on past happening, this is what's going to happen. Right? So how do we do predictive analytics? How do we predict the future? Is it even possible on Excel? Does anybody have any idea of how to do predictive analytics?
No, well, I think to predict, you have to look at the past.
Okay. So we have the past. This data was from 2021. Maybe it's not noted here, but this data was from 2021. We got data from 2021 and across the states. So is there any way this data can tell us what will happen in 2022? Or what was going to happen in 2022? Is there any way we can forecast? Is there any way we can forecast? Is there any way we can forecast? Are we familiar with this function? Are you familiar with linear forecasts? As we can see, it says returns the forecasted value for a specific future target date using exponential smoothing method. That's this one. Each of them has their different types of forecast. This one includes seasonality. This one gives us a linear forecast. While this one just tells, it uses exponential. We're just going to use equal to forecast. Then what this is called a naive forecasting method, right? This is naive forecasting. So naive forecasting. Naive forecasting. So we could actually forecast, but we can't forecast along the columns, right? And we can't forecast along the rows because this is only one data point for 1 year. This is ABIA 2021. If we had ABIA from 2011 to 2021, we can now forecast for 2022. But we don't have that historical data. So to forecast, we need historical data. Historical data for forecasting, whether it's naive or not. Now, if we had historical data, right, there are more sophisticated ways to forecast now. And when you start Python, I think you will thoroughly understand what we are talking about. So first, you will hear things like training data. You will train data, right? You will train it. Then you will test it. You will test the data based on how you have trained it, right? So if we had historical data for a state, for example, the contrastive prevalence data in Abia State for the past 10 years, we would have been able to do that. But unfortunately, Nigeria is a very data poor country, right? We don't measure things. We don't have a culture of measuring things. And if you want to do research to measure, the government will tell you that they don't have money. Government funding on healthcare is very low. So, but if we had another data set, maybe from another place, maybe finance, for example, finance data sets, you can have finance data sets for the past 10 years. I don't know if you guys have done that. There's one assignment that Dr. Francis used to give, or that they used to give in data analytics. Data analytics, that's the course now in LBS. Data analytics, where they will ask you to take the past 10 years data from a financial institution and then forecast it, right? So that is what you are doing there. You can actually take that data and forecast, but that would be naive forecasting. So get ready for train test splits. Train test splits. It doesn't make sense now, but when you start Python, it will make sense. So with Python, we can take historical data, train it, and use it to create a data model. A model, right? This model, we can use it to now predict. So a predictive model. So predictive analytics tells us what will happen. We don't have that here. So unfortunately, we can't do that. I wish we could lay our hands on any historical data sets. We would have done some forecasting. They would have quickly done some forecasting. Sorry, Noye, I don't know, is Noye still on this call? Whether she has
I'm still
any,
here.
okay, whether she has, do you have any historical data sets?
No.
But if there's none, it's fine. It's fine. Right?
Okay.
But the function, just know that the function for a naive forecast is this equal to forecast, right? And then there's another more sophisticated method of doing forecasts where you can use moving averages. It's a common exam question in EEGB for those of us who have not done it. But yeah, if you've done that, if you did that, then you will know. I'm sure you already understand what we're talking about.
And
right?
OPM as well. Let me add.
Oh, okay. It's now in OPM now. Interesting. On OPM, yeah. So that's that about predictive analytics. I'm sure when we get to Python, it's the main analytics we're going to do in Python. Then prescriptive analytics. So what should we do? Right? What should we do? What should we do usually takes off from what has worked in the past. Right? So, and it's usually based on what has worked, what's why the problem happened. So it prescriptive analytics builds up from this, right? So it tries to build up from this. So if we know that, if we assume that literacy rate, or we're able to confirm that literacy rate is a driver of contraception, and we want to increase contraception. So the question we'll now ask ourselves is, okay, now that we know that this is a driver, but if we reduce literacy rates, a 20% reduction or increase, a 20% increase in literacy rates will result in X levels, X increase, X% increase in contraceptive rates, right? So it tries to measure if we do this, right, if we reduce this by 2 or by 20%, by how many would the other side go down? If we increase this by 20%, by how many would the other side go up? So that's I don't think we can cover that here today, right now. We have just 15 minutes left. And we would also, the next step will now be to have an autonomous or adaptive analytic system. This is where you now talk about automation, automated processes, where this part, you only get it with advanced tools, not just like R, Python, but not just that. This is where things like apps come in, right? Where you're not even thinking. So if anybody who has ever traded, who has ever done investment trading, you might have heard of bots, machines that you just put your money and the machine will just be trading for you, right? So those are automated or adaptive, automated or autonomous or adaptive analytics. It just takes other people's trades that other people have been trading, right? Or that observes their patterns and then does the same thing. It basically just copies. So it does it in such a manner that you don't have to think, you don't have to apply yourself. It just keeps going, right? So I think thus far we have some of these things you already knew beforehand. Some of these things are just refresher courses for you. But I thought to come and share this data, this analytic session today, because this is actually something that some people are working on for the government, right? Trying to understand where the problems are and why there are problems and what will happen in the future and what should we do about it. And by the time we start solving these problems, are there ways we can automate it? So these were the what's the word now? This was the flow of thoughts of the analysis as the governments, people are currently doing this in Abuja right now. So we don't have all the data sets. Maybe they do, but we don't have all the data sets here right now. But I just felt like if we understand the way this works, this same process, what is happening, why is it happening, what will happen, what should we do about it, and how do we automate this process? If you have this sort of framework for thinking about analytic problems, right? It really helps in any field of analytics you want to do, whether it's in oil and gas, whether it's as long as it's a problem that needs a solution, this framework works. You should think about it using this framework. So, Noye, are you there? Okay, well, she must have left, she must have stepped up, but I think that this would be a very nice place to hang the curtain, no, draw the curtain. And then hopefully from the next time we meet, we can now move into proper predictive analytics on Python. Today, what we did mainly was descriptive and diagnostic, but we can move, and when we start Python, probably from next week, we can now start looking at why things happened. So train, test, split, and finding out why things happened, that's Python. And that should start from next week, or let me just say it's Python, so Python. So this would be a very good place to draw the curtain, right? Are there any questions, complaints, comments, thoughts before we go? Any thought?
I don't think there are any comments on it.
Okay, okay. So without further ado, thank you for your time. Thank you for listening. And I wish you a pleasant rest of the day.
Thank you so much, IG, for taking our time to take us today on such short notice. Thank you so much.
That's why we are here. Happy to do so. All right. So bye everyone. Bye everyone. See you next week. Sunday by God's grace.
Bye.